right-angled triangle trigonometry, finding unknown sides, the second video, solving for the denominator. When we're finding the unknown sides of a right-angled triangle using trigonometry, our first step is to label the sides relevant to the angle, opposite, and hypotenuse. We don't label this side because there's nothing meaningful on it. We choose our ratio based on which sides we have. Opposite and hypotenuse means we're going to use sine. We write the ratio, sine theta equals opposite over hypotenuse. We substitute in our values. Sine of 35 degrees equals, opposite is 5 over x. This is where this deviates from the previous examples we've seen, because x is the denominator. X is not at the top of the fraction. Now, to rearrange an equation like this, our first priority is to get x up to the top, up to a numerator. We can't do anything with an equation where x is on the denominator. So we've got 5 divided by x. To get rid of this divided by x, we have to multiply by x on both sides. And you wouldn't normally show this, I'm just putting a little reminder as to what we're doing. So that means we've got x times sine 35 degrees equals 5. Now I want x on its own. I've got x times sine 35 degrees. So I will need to divide both sides by sine 35 degrees. Again, we wouldn't show this in our working. To get x equals 5 divided by sine of 35 degrees. And x equals, check that we're in degrees, 5 divided by sine of 35 degrees. X is 8.7. Now, what you'll notice has happened is that the x and the sine of the angle have effectively switched places. As long as you can remember when that happens, I'm okay with you skipping this line of working but this line of working does really support you to get the right answer. So if you're at all uncertain, if you don't know why x ends up here and it's divide by sine 35, then follow the appropriate working. You need to be able to solve an equation. If this is confusing you, watch the video that I'll put up about solving equations, because you do need to be able to do that. We'll do a second example. We've got two unknowns here. So I have opposite, hypotenuse, and adjacent. This means that I can choose whether to solve for x or y first. So I'll choose x, and that means I've got opposite and adjacent, so I'm choosing tan of the angle is opposite over adjacent. Substitute the values. Opposite is 19 over the adjacent, which is x. Remember, we multiply both sides by x to get x up to the top, and we divide both sides by tan 28 to get x on its own. And x will equal 19 divided by tan of 28 degrees, 35.7. Now, you also have to find y. You have two choices. You can use Pythagoras. If you use Pythagoras, you must keep more decimal places. This has been rounded. You would have to keep more decimal places. X equals 7338. to put into your calculation, because a rounded answer should never be used in the calculations. You would round and keep a lot more decimal places. Or you can use trig, because now I know the value of this side. There's nothing to stop me using trigonometry to find the value of this side. So let's feel warm and fuzzy about Pythagoras. Make sure you keep enough decimal places. So if I'm going for 2 decimal places in my answer, I keep at least 4 decimal places anywhere else. Find the square root. And y equals 40.47. So finding the unknown sides when x is the denominator, be really, really careful that you solve your equation correctly, because it is not quite as easy as the previous types of questions.